Hey guys, let's quickly talk about DNS services. Now, DNS solves the issue seen with environment variables by allowing us to reference the services by their name. As services restart, scale out, or appear anew, the DNS entries will be updating and ensuring that the service name always point to the latest infrastructure. DNS is set up by default in most of the supported providers. Also, a word of note is if DNS is supported by your provider but not set up, you can configure the variables as you can see at the top of the screen in your default provider config when you create your Kubernetes cluster. So with DNS, active services can be accessed in one of two forms, either the service name itself, which is a service hyphen name, or a fully qualified name that includes the namespace, which is service hyphen name dot namespace hyphen name cluster dot local. So in our example, it would look similar to as I have quoted it here. Okay. Now let me quickly move to multi-tenancy. Now Kubernetes also has an additional construct for isolation at the cluster level. In most cases, you can run Kubernetes and never worry about namespace. Everything will run in the default namespace if not specified. However, in cases where you run multi-tenancy communities or want broad scale segregation and isolation of the cluster resources, namespace can be used to this end. Now to start, Kubernetes has two namespaces. First is default and other is Cubase system. Now Cubase system namespace is used for all the service level containers we saw earlier. The UI logging, DNS and so on are all run in Cubase system. Everything else the user creates run in the default namespace. However, our resource definition files can optionally specify a custom namespace. For the sake of experimenting, let's take a look at how to build a new namespace. First, we will need to create a namespace definition file like the one in the listing as you can see on the screen where I am pointing out right now through my cursor. This is basically a test-ns YAML file. We can go ahead and create this file with our handy create command as you can see here. Now we can create resources that uses the test namespace. The following as you can see here is an example of a pod using this new namespace. This is say ns -pod YAML file. Now, while the pod can still access services in other namespaces, it will need the long DNS service like service -name dot namespace -name dot cluster dot local. As you can see in the example, if you or for example, if you were to run a command from inside the container in the above code, you could use node-js node-js default cluster dot local to access the node.js, and I'm not writing out here on the screen because we have already done it. Now here is a note about resource utilization. At some point in the lectures you may run out of space on your cluster, so to create new Kubernetes resource the timing will vary based on cluster size, but it's good to keep this in mind and do some cleanup from time to time. So we can use the following commands to remove old examples as you can see here at the bottom. Let me quickly go to the next piece, which is about limits. Now let's inspect our new namespace a bit more. Run the describe command as follows as you can see on the screen here. The following screenshot is the result of the preceding command, this one. Kubernetes all allows you to both limit the resource used by individual parts or containers and the resource used by the overall namespace using quotas. You will note that there are no resource limit or quotas currently set up on text namespace. Suppose we want to limit the footprint of the new namespace. We can set quotas as follows, as you can see here. A word of note there is that this would be quota.yaml file, and in reality namespace would be for larger application communities and would probably never have quotas this low. We are using this in order to ease illustration of the capability in the example. Here we will create a quota of 3 pods, let's say one RC and one service for the text namespace. This is executed once again by our trusty create command, which we have been using for a while, and the command is well written here. Note that we have that in place. Let's use describe on the namespace as follows. This is the following screenshot, the one which you see, is the result of the preceding command. Let me quickly go to the next slide. You will note that we now have some values listed in the quota section and the limit section is still blank. We also have a used column which lets us know how close to the limits we are at the moment. Let's try to spin up a few pods using the following definition. And this is a file in YML, let's say busybox-ns YML file. You will note that we are creating 4 replicas of this basic pod after using create to build this RC. Run the describe command on the test namespace once more. You will notice that the used values for pods and RCs are at their max. However, we ask for 4 replicas and only see 3 pods in use. Let's see what's happening with our RC. You might attempt to do that with the command here, and here this is the command which I am talking about, this one, and this will let us see what's happening with our RC. However, if you try, you will be discouraged to see a not found message from the server. Now this is because we created this RC in a new namespace, and kubectl1 assumes the default namespace if not specified. This means that we need to specify namespace is equal to test with every command when we wish to access resource in the test namespace. We can also set, by the way, this is a point to note again, we can also set the current namespace by working with the context settings. First, we need to find our current context, which is found with the following command, and you can see the command for context. Next, we can take this context and set the namespace variables like the following. Now you can run the kubectl1 command without the need to specify the namespace. Just remember to switch back when you want to look at the resource running in your default namespace. Now run the command with the namespace specified. If you have set your current namespace as demonstrated, you can leave off the namespace argument. Now let me quickly go to the next screen. Now after giving this command, the following screenshot is the result of the preceding command. Yeah. So as you can see in the preceding image, the first 3 pods were successfully created, but our final one fails with the limited to 3 pods error. This is an easy way to set limits for resources partitioned out at a community scale. It's worth noting that you can get or set quotas for CPU memory, persistent volumes, and secrets. Now, additionally, limits work in a similar way to quota, but they set the limit for each pod or container within the namespace. A note on resource usage before we start using it, as most of the points wherein we have had discussion and we explained, we need to specify that we have utilized GCP or AWS. It can be costly to keep everything running. It, it's also easy to run out of resources using the default cluster size, especially if we are keeping every example running. Therefore, you may want to delete older pods, replication controllers, replica sets, and services periodically. So we need to clean it up. You can also destroy the cluster and recreate as explained earlier in the earlier parts of the lectures. Okay, so before we close, let's quickly summarize it for a while. We took a very deeper look into networking services in the Kubernetes. We should now understand how networking communications are designed in K8s and feel comfortable assessing our services internally and externally. We also saw how kubeproxy balances traffic both locally and across the cluster. Additionally, we also explored the new ingress resource that allows us more finer control of incoming traffic. We also looked and understood briefly about how DNS and service discovery is achieved in Kubernetes. And we also finished off with a quick look at namespace and isolation for multi-tenancy. So this wraps up this piece. I'm sure this will be very helpful for everyone. I'm taking a pause here and till we start next lecture, see you soon.